Hello, algebra students. This will be the review for your final for semester 2. Hope this helps. For the first one, you are tasked with solving a system of equations by graphing. And so you need to graph both of these linear equations. Oh, remember linear equations? Weren't they easy? And then find the point where they intersect, because that point is the coordinate, the x and y value that makes both, not just one, but both of these true. So the first one here, we've got a y-intercept of positive 2, and then we have a slope of negative 3, so we would go down 3 from that point over 1, down 3 over 1. You could also go up 3 to the left one, connect our dots, and we've got our line. Now we've got the second one, y equals x plus 6. So we've got a y-intercept of 6. The invisible number here in front of the x is 1. As a fraction, be 1 over 1. So rise 1, run 1. And you wind up with this line right here, and they cross at negative 1, 5. Make sure that you write that solution, not just graph it. For IC 3 or 5, depending on how I feel, you've got a system where you need to solve it algebraically, either by using substitution or elimination. Here I would strongly suggest using substitution. You know what x equals, it's negative y plus 12. So you're going to take that negative y plus 12 and you're going to substitute it in for x, which is what it equals. And then once you do that, there are no more x's, and you can just solve for y. We're going to do the distributive property, so negative 3y plus 36, and then of course minus 2y equals 6. Combine some like terms, negative 3y minus 2y be negative 5y plus 36. Now we've got a nice little two-step equation. We subtract 36 from both sides, and then divide both sides by negative 5, and you wind up with y equals 6. But don't stop there. You also need the x-coordinate, just like you needed the x-coordinate up there in the first one. So we plug in 6 for y. You can pick either one. I chose the one that directly solves for x. And so I get negative 6 plus 12, which is positive 6. So my solution is 6, negative 6. For IC 7, 7.1, where we delve into exponents and your exponent properties. So the first one here, pretty simple. Just do you remember that when you have exponents with the same base, you add them. So p to the 8 plus 7 is p to the 15th. Here we've got a little bit more work to it. Remember that you not only square the thing with the exponent, but you also need to square the coefficient out in front here. And negative 4 squared is actually positive 16. And then when we have an exponent to another exponent, we multiply them. So 3 times 2 is 6. And then when we combine them here, you need to multiply the coefficients together. 16 times 6 is 96. And then again, just like the first one, when we have exponents with the same base, here they both have x, we add them. And 6 plus negative 3 is 3, so 96x cubed. Okay, for IC 7.2, putting together some different exponent rules, we've got a fraction to it, an exponent here. So remember that you need to square the numerator and the denominator. And when you do that, not only do you need to kind of do that, you need to take care of the coefficient as well, just like last time. So 9 squared is 81, and 4 times 2 is 8. 10 squared is 100, and 3 times 2 is 6. All right, final one here on this first section. Sorry, I wrote that. All right, so we've got a little bit of everything. Oh shoot, got cut off here. Well, I think it was 8 over 2, and that's where the 4 came from. And then we had x to the 0 divided by x to the 6. Well, when you have exponents with same base and you're dividing them, you subtract. So 0 minus 6 gives us negative 6. And then negative 7 minus negative 3, well, that'd actually be like adding it. So negative 7 plus 3 is negative 4. Either way, you still have negative exponents. You can't have those in your final answer, so I turn everything into fractions. 4 becomes 4 over 1. X to the negative 6, you got to remember that that is the same thing as 1 over x to the positive 6. Same thing, y to the negative 4 is 1 over y to the positive 4, and then I multiply them and put them all back together. 4 times 1 is 4. 1 times x to the 6 times y to the 4th is that. Okay, on to the second section. Still working with some exponents. You need to write the function for the given table. So remember that the general form is y equals a times b to the x. A stands for the y-intercept, and b stands for the rate, the number that I multiply by to get to the next number. Well, the y-intercept is easy. It's the y value when x equals 0. And so the y-intercept is 4. That's why that goes there. And then the rate, b, is the number that I multiply by to get to the next number. So I take a look, maybe an easy one. These ones are kind of hard to figure out. So I look at this one. What do I multiply 4 by to get 6? Well, if I didn't know off the top of my head, it's, all right, 4 times what gets me 6? Well, I divide both sides by 4 here, and oh, look at that. b equals 3 over 2. I multiply each one by 1.5, and that would get me to the next number. And sure enough, that's the number that I put there. All right, for 7.5, now you're graphing. And so, well, again, you're applying the same principle. 6 is my y-intercept, so that's why I have a big dot there. And then I'm multiplying by 0.3 each time to get to the next number. So on my calculator, I just took 6 times 0.3, and I got, I think, about 1.8. And then I took that and multiplied it by 0.3, and I got my next number and my next number, and until I had enough dots that I thought I could successfully draw my function. For the domain, you can see all real numbers. It goes forever that way, it goes forever this way. In fact, I mean, it'd go really high, but it's possible. For my range is all real numbers y greater than, not or equal to, just greater than 0. It will never actually get to 0. It'll definitely never cross 0, and so they will always be positive. This was one that a lot of groups struggled with on the exam, or on the milepost test. You're still working with the general exponential function. Y equals a times b to the x. It's just a, this time, stands for the initial amount, which is still like the y-intercept, and you invest $10,000. Well, that's the initial amount, so that's why that goes right there in the y-intercept spot. And then if you've got a return of 7.5%, that's an increase. Well, you can't write 7.5 in here. We're not multiplying by 7.5 every year. We're multiplying by 0.075. Well, not that, but 1.075 because it's increasing, and we've talked earlier this year about why we would have the 1. But you know, we want to find the balance after 9 years, and so we'd plug in 9 for time. There, the exponent. We're multiplying by 1.075 9 times, 9 years, and we wind up with 19,172. All right, moving on to fourth quarter things. ICANN statement number 8.2. Just combining some fractions. You got subtraction here, so 2y cubed minus negative 2y cubed. Well, 2 minus a negative would be like adding, so 4y cubed. Please don't put 4y to the 6. You don't add the exponents like you did over here. That's when you had the same base. Or sorry, when you're multiplying. These ones over here, you are adding. So you do not add the exponents. 6y squared minus 3y squared would be 3y squared. 6 minus 3 is 3. Negative 5y has nothing to match up with, so I just leave it. But here I have minus 9. But don't put minus 9 down here because it's like saying 0 minus negative 9. So it would actually be like 0 plus 9, which is plus 9. 8.3, you're doing some multiplication. So you've got this one right here. You've got y times y squared. So now you do have a common base, and you're multiplying. So you add the exponents. 1 plus 2 is 3. Then y times negative 4y is negative 4y squared. You keep doing the same thing now. So you did the distributive property with each one of these. Now you got to do it with the 3. And you wind up with these 3 terms. Now you got to combine any like terms. We have a couple. We've got y cubed, matches with nothing. Negative 4y squared plus 3y squared. So these two match up. And I'll add them just like I did up here. So negative 4 plus 3 is negative 1, so negative y squared. The negative 2y matches up with the negative 12y. Negative 2 minus 12 would be negative 14y. And then nothing matches up with negative 6, so I just put it there. All right, 8.7, the final one on the front page. we're going to solve the quadratic by factoring out the greatest common monomial. We've got the binomial here. And the biggest thing that I can divide both of these things by is, well, 2. I can divide both 6 and 14 by 2, but I can also divide them by x, because they both have one x in them. This one has 2, but this one doesn't, so the biggest thing I can pull out is the 1x. So that's why I've got, this is the greatest common monomial, 2x, and I divide both of them by 2x, and what would happen is I get 3x plus 7. To check my work, I can just do the distributive property, and I should wind up with this again. Now, because this equals 0, I can use a zero product property. And, well, what values for x make this equal to 0? Well, on one hand, if x equals 0, 2 times 0 is 0, so I get 0. 0 is a solution because 0 times whatever this winds up being is equal to 0. It's a true statement. And then over here, what value for this makes it equal to 0? Well, I just over off to the side say, all right, 3x plus 7, what value for x makes this equal to 0? I do the little two-step equation, I get negative 7/3. So when x equals negative 7/3, this part will be equal to 0. Doesn't matter what that is because 0 times this is equal to 0. All right, you can look on the other video for part 2.